deal with things like this. We haven't seen addition yet with radicals, so now we're going to look at addition. And when we're looking at addition or subtraction, we kind of deal with these the way we would with variables, right? As if they were x's or y's or something like that. So if you see something common between two expressions or between two terms rather, then that's always a good thing. Like the square root 11, for example, is common, which means we can simplify this by, in a way, factoring out the square root 11. So I can rewrite this as, the first one I'm going to do it the long way, just to show you guys what's actually happening here. This is 3, this thing will write 3 plus 7, and you can factor out a square root 11. So that's 10 square root 11. Okay. You could go from the first step to the last step in one go if you wanted to. I'm just showing you in the middle what's actually happening. Okay, and the second one is a similar thing, but now we have two different independent square roots here, which are not the same thing. But there's 2 square root 2, then 2 square root 3, so we can at least combine those together to get some kind of simplification. So I'll rewrite this here. Let me just put the like ones together. 5 root 2 plus 2 root 2, root 3 plus 4 root 3. And then we can just put them together. So the 5 and the 2 on this side will give us 7 root 2. On that side, the 1 and the 4 will give us a 5 root 3. Leave that up for a few seconds. If anyone is not sure any step, please let me know. Yeah, that is. There's nothing much more we can do. Okay, now the third one. It probably looks a bit sinister, but it's not really so bad. So the third one, I think we can see a square root x, which is common here. So we can combine those two. Let me just write that. So 3 square root x plus square root x, we can combine those. And this other one, I don't think we can do much with it. 12 cube root of xy. That's not common with anything else, so we'll probably just leave that aside. And we can rewrite this as 4 square root x plus 12 cube root of xy. But I don't think we can do anything further with this. Yeah, because it's a cube root of x, so nothing much we can do about that. Good. Yeah, I know. Yep. It wasn't it was just a square root, then yeah, we could have pulled out square root x. So I can show you that on the board so people don't get confused what I'm doing. If it was like a 4 root x. So saying this is just a square root x, I'll write it like this. Then we can just then we can pull it out, right? Okay, I'll pull it out on. Okay, let me just 4 plus 12 is equal to 5. I could write it like that. You could, maybe we should do that. The 4. So 1, 2, 3. Okay. Okay, guys, let's do the last one. I'm not seeing any pattern here, so let's see what we can come up with. Let's see, what if we write this as, so some of these you have to inspect them a little bit and try and find things common. So because there are two square roots here, we can probably pull things out. So what can I factor here? It's all about factorizing here. X in the beginning, we can't do much about that. Okay, let me write it like this so we can see what I'm doing. Cube root of x times y times y times y times y. I'm not sure if that's necessary, but in case it helps anybody. Here we see x, 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 y. So now it becomes clear what's common here. I can pull out a single x and a single y from the cube root, because that's common to both. Okay, so let me do that. What if I pull out a cube root of x, y, and then just see what's left over after that? We have here, it is so confusing now, whether it's x cubed or a cube root x. In an exam, I don't know how to tell what's what really. That could be x cubed or cube root x. I mean, cube root of something. So how do you differentiate them? If it's ambiguous 100%, then
on this other slide, you have the medical side, you can see that it's pure rather than the power.
yeah. Okay, but again, don't worry too much about that, because if there is ambiguity, then I'll mark accordingly. I'll have to mark both right. Okay, but here we know it's a cube root because of the theme we've been dealing with all this time. So as I said, what I'm pulling out here has been pulled out already. So what's left is now x cube root of y cubed, because I pulled out, yeah, plus y cube root of x cubed. Is there y here? Just x cubed. cy4x. Yeah. So this intermediate step is not really necessary, but if you need to do that, you can do that. Okay. So essentially, these are all just factorizing problems. Just find what's common, pull it out, and then whatever is left, add it if it's possible, subtract it if possible. Otherwise, just leave it alone. Like here, we can't really add these two together, so we just leave it alone. X cubed. The second term.
Inside the bracket, also brackets.
The first one. There should be an x cubed inside there. Cube root. Just show me where you're looking. Yeah.
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 3 years.
Oh, the cube root. Oh, that's what it's saying. Okay, yes, that's right. Thank you. Cube root.
But it's 3 and white.
Yes, because it's a cube root, you're right. We can simplify that further. Yeah. So we just add them. Okay, yeah, you guys are right. Well spotted. You can simplify it further. If you've done that, well spotted. xy. So because it was a cube root, this will then become xy plus yx, or just xy, which is just, we can then pull a 2 out here. You xy, xy, and then we can probably go further than that now. I mean, we don't have to though. It'll become a bit messy if you write this as xy to the power 1 plus a half, which becomes xy to the 3 over 2.
No.
But it's not necessary. Okay, let's leave it alone. Leave it alone. Oh, yeah. That's the final answer.
So, yeah, it's fine.
Which was
Some changes. But okay, why? Then let's really that's okay, we got that. We got that. That's fine. Why? One, two, three. What we like to yeah, that's it. Oh wow.
sorry. How are you?
That's because after the factor, let me check this after this because it's gonna finish this project. So I'll finish it only up. So the section is done. Okay, guys, last thing we have to look at before complex numbers is solving radical equations. So again, I'm going to try and get through this a bit quickly. Let's see, should I ask you guys to try this one? Anyone has an idea what you would do for the first one here? We'll do it together. Yeah. Yeah, so that's what I'm looking for, right? You guys are both speaking to me at the same time, but I think I got what you're both saying. Okay, so I heard square both sides, kind of from both you guys. Okay, so it's easier to first move the 3 to the other side and then square both sides. So here, remember, always try and get the variable alone to one side before we do anything. That's always helpful. So we rewrite this as square root x is equal to 5 plus 3. Should I write that? 5, 6, 7, or just write it one time? I hope you guys know what I'm doing here. Yes. Okay, and then we square both sides. So let me just think now. We're going to get a plus minus here, will we? Square root x squared. No, because the square is on the outside. So does it give us a plus minus? Let's think for a second. No, I don't think it would. Because yeah, but it's kind of opposite. So this here is square root x squared. Usually we look, the absolute value would have been that way. That's absolute value. This one here shouldn't be because the square root of something, we take the principal square root. And it doesn't matter what you get because then you square it, so it must be positive. Okay, so this should be positive. It's a bit weird, but yeah. So this, if you square both sides, you will just get, okay, let me just write it. No, that's 60. Okay. Yeah, because you put a negative, then it'll break the equation. Yeah. Okay.
The give and take.
Okay. Question 1, you guys okay with simplifying that? Okay. So if you guys are okay with this and you're kind of falling asleep, it's okay, as long as you know what's happening. But the next section, I need everyone's attention. Complex numbers. So if you need to have a power nap or something here, if you understand this, do what you need to. But just now, we'll need your guys' full attention. Okay, this other one, number 2 here, we just immediately square both sides, right? That's the way you do this one, and you get x plus 8 is equal to 9, and then blah, blah. You guys know the story from there, right? Solve for x. Okay, this other one, similar thing, we just move the 1 to the other side. Square root 2x plus 3 is equal to 6 minus 1, which is 5. Then you square both sides and do the thing. Yeah. Okay, thankfully we're done with that. Now we look at complex numbers. So guys, this is where, if you haven't seen this before, I need your attention here. So complex numbers it comes up as a way to deal with the square root of negative numbers. And it invents a whole new thing, which it's interesting because it gives us an insight into different physical properties of the world as well. Right, so I'm not going to get too much into the physics of it. Anyway, the whole thing comes out of defining this thing here, which is I, which is given by the square root of -1. So that definition is what makes complex numbers work. So just, you need to remember that one off by heart. We know the square root of -1 is usually undefined. We don't deal with it. Here we label it something, and we don't try and simplify it. It's like a variable sort of. Well, not a variable because it doesn't change. It's a label for a constant, and we just keep it here all the time. Okay, so for example, keeping that in mind, if I ask you to simplify the square root of -4, we would rewrite this as square root of -1 times 4. We can do that and break that up using our rules into -1 and a +4. Then the square root 4 becomes a 2. And the square root of -1 just becomes an I. So better to write it the other way, 4i. That's how you simplify something like this. So it's not really difficult. It's just a matter of remembering. Yes. 2i, sorry. 2i, thank you. Thank you, thank you. That's why guys are looking at me like that. 2i. Yeah, don't stress, guys. If you're ever in doubt and you think who's wrong between the two of us, it's always going to be me. So just ask, right? This one here. So because -1 times 4 is the same as -4. So I just rewrote -4 as this. Is that okay? Yeah. Then you can just break up the square roots using the rules we got before. And the reason we do that is just to get this alone, but we can rewrite that as I. Yeah. Okay, let's try this one at the bottom. We got a negative in front, and we keep that there. We just don't interfere with it. Negative squares. Maybe I should give you guys like 20 seconds to try this one before I do it. Give it a try. Let's see if you get the hang of it. Just be careful with the negative on the outside. Don't forget about it. Yes. This part here. It's exactly the same. It's I multiplied by 2. I'm just saying you can rewrite it like this. It depends which one. What is square root of 72? 7. No, that's not it. No. Oh, it's not a nice one. Okay, thank you. I was panicking here for nothing. 602. Thank you. Okay. Yeah, so it's not a decimal. Okay, guys, square root 72. It doesn't give us a very nice number. It gives us 6√2 as an answer. Yes.
What happened to the minus? The minus.
The minus should still be there. I just dropped it for some reason. It should still be there.
Oh, okay.
Yeah, thank you.
Yes.
If you guys want to get messed up, bring a bottle here, and every time I make a mistake, take a shot. Each time we're done, we finished.
Drink recording.
Drinking is bad. Yeah. Go down further. Go up. Okay. Hey guys, this is new stuff. So any questions so far? Questions?
Yes.
Yeah. No. Whenever you see this, you just keep it at this.
Yeah.
Question? Okay.
Just like no, it's just how does it go? I would say if you want to I'm just important. I'm think I think it was I think it would be nice. I think I'm gonna get the the same. So if you go to get the apple, we get to so we have this right.
Okay, so guys, if we now digested the idea of dealing with the square root of -1, let's try and use it in the kind of problems we will see. So let's see, how many problems do we have here? A fair amount. Okay. Okay. Okay, I'm not going to rush this. If we don't finish it today, it's okay. This is all new stuff. So if you're given simple operations to apply with complex numbers like adding and subtracting, these are not too difficult to do. So we'll start with these. If you're given two complex numbers, maybe I should mention the form of a complex number. So let's note this on the side here. A complex number is usually written as a plus bi. I'm going to write this as, usually sometimes they denote complex numbers as z. So this right here is the form of a complex number where a and b are just some real number. So a plus bi, right? Take note of that form. This is very important. All complex numbers need to be written in this form. So if you ask to show your answer as a complex number, you show it in this form. Some real part plus some part with an I. Okay, so I mean, we can see all the examples at the bottom have this form. Add these two numbers together, both of them have the form something plus something with an I. Or minus, plus or minus. Okay, so adding these two numbers together, we just take the real part, add them together, take the complex part and add them together. Or I should say the imaginary part, because that's what we call it. The part with an I is called imaginary. Okay, so what we do here is write this as -3 plus 7 on one side, 3i minus 2i on the other side, 7, 6, 5, 4 on this side, and plus 1i, or just 4 plus I. So again, you just put the real part together, you put the imaginary part together, and you deal with them separately. Okay. Okay. Did I lose anybody here? Maybe I should write it as well in case anyone needs to remember these terms here. A here is called the real part. The I is called the imaginary part. Spelling is failing. I am imaginary.
It's enough. Okay. Appreciate that. That's a good consideration. That's what I give to very recent. The other problem we just don't have to make each other think better. This math is making your shallows imaginary. But the thing is,
Okay, guys, I'm not going to push too much. Can we manage one more example?
Yep.
All right, last one. Do you guys want to try it by yourselves first?
Yeah.
Last one. Okay. Give it a try. Last one. Okay, so this one shouldn't be too long. -3 plus 3i, there's a negative outside brackets, which means we have to distribute the negative. So it becomes -7 plus 2i. Okay, so -3 minus 7 on one side, plus 3i plus 2i on the other side. So this becomes -10 plus 5i. Guys, everybody with me? Okay, then if you guys want, you can try the others at home, but they are a little bit complex. I'm trying not to complex, right? Okay, so guys, the common mistake with these is people forget to distribute the minus sign. Just check if everyone's okay with that.
Oh, my.
Okay, guys, I'm still going to be here for some time, but if you want, we can call it off at this point. Have a good weekend. I'll see you guys next time. If you need help, I'm still here. You can come ask for help.